Alright, notes for 7.2, similar polygons. So the first thing you have to do is recognize whether or not polygons are similar. So for polygons to be similar, there's two things that have to be true. Corresponding angles have to be congruent. So we look here in the trapezoid, those are congruent, and those are congruent. Okay. Next, the sides have to be proportional. So 6.8 over 19.3. So what I'm going to do is I'm going to write 6.8 over 19.3. Then what I'm going to do is I'm going to use my calculator and I'm going to simplify that doing my math frac button. So 6.8 over 19.3, and that gives me 68 over 193. Then I have to check the other sides. So I have to do 10 over 23. So if I do 10 over 23 and then do math frac, I just get 10 over 23. Well, these are not proportional. They're not the same ratio. So no, those polygons are not similar. Alright, what about the next one? So again, look at angles. Well, this one says 105, that one says 100, but what I need to notice are my segments, okay? In other words, this has two arrows. My two arrows here are going sideways, which means this one's actually flipped. So the way it should really look is kind of like this, where this would be 8 and 8. This would be 10 and 10. Now, where would the 100 go? The 100 would be down here at the bottom then if you flip it up. So this is 100 right here. Okay. Now, again, angles have to be congruent. So since these are parallel, remember, consecutive angles have to be 180. So that would be 75. Well, then I look, those angles don't line up. They're not the same. So no, those are not proportional. Okay. Or similar, sorry. The next one say the polygons in each pair are similar. Find the scale factor. So you got to look at how the figures line up, but another way to do this is just remember this. Small has to go with small. Okay, small has to go with small. Big with big. Now, again, you got to be careful here about the pictures. The problem with the 6 and the 15, they don't actually match up, because if I took this figure right here and I turned it to look like this one, here's where the 6 would be. So if I take that same shape and I just make it a little bit smaller, and that's not very good, but the 6 is actually right here, which does not correspond to anything right here. I don't know why my pen's not writing again. Okay? The 8 is right here. Well, the 8 does correspond to something. The 8 corresponds to the 20. So that's going to give me my scale factor, and it says smaller figure to large. So I put 8 over 20, and then I do math frac. I reduce that again. So 4 goes into that 2, 4 goes into that 5, and that's my scale factor. You might see it written again like this. We did that in lesson 1. Okay. Here it says they're similar. It wants us to find the missing side. So again, you got to pay attention to how the figures are turned and everything. So here, the 12 goes with the 15. So I have 12 over 15. Now what I'm doing here is I'm doing small figure over large figure. Well, whatever I do to this side, I got to do to the other. So I got to do small figure over large figure. Okay. What's the measure in the small figure? The measure is, I'm going to use red here, 16. What's the measure in the large figure? That's what we don't know. Question mark, or I'm going to put an X. So then we cross multiply. So I get 12x is, so I'll get my calculator here, do 15 times 16 is 240. Then I divide both sides by 12. If I do that, I get x is 20. So then that means the question mark would be a measure of 20. Alright, two more. It says solve for x. The polygons are similar, so very, very similar to what we just did. So again, set up your proportion. So in problem number 5 here, I have, now the figure's turned, so the 2x minus 2 goes with the 3, and the 36 goes with the 6. Just remember, do it the same way every time. So I'm going to do small over large. So I'm going to do the small figure, which is 3 over the 2x minus 2, because those go together, and then 6 over 36, because those go together. Again, cross multiply. So I'm going to do distributive property here, so I'm going to skip a step. 6 times 2x would be 12x. 6 times 2 would be 12. Do 3 times 36, which is 108. Add 12 to both sides. So that gives me 12x is 120. Divide by 12. And I get x is 10. Alright, problem number 6. Okay, so match them up again. The 5 and the 10 go together. The 16 and the 2x minus 10. So again, decide how you want to do it. I'm going to stay with small over large. So I'm going to do, in this case, 5 over 10. That's the small figure right here. That's the small one. 5 over 10, and then 2x minus 10 goes with the 16. Again, cross multiply. I'm going to skip a step. 10 times 2x would be 20x. 10 times 10 would be 100. And then 5 times 16 is 80. Add 100 to both sides. You get 20x is 180. Divide by 20. And then you get x is 9. So hopefully this makes sense as to why we learned proportions and ratios in the first lesson.